Hello everybody, my name is Davins, and for my capstone presentation, I'll be talking about a little bit about anesthesia. So you may be asking, well, what is anesthesia? I'm going to tell you. Anesthesia is just a branch of medicine that focuses on relieving pain before and after surgery. Many people have different surgeries in the years, and maybe you've seen this with different anesthesia, whether it kind of makes you kind of woozy, a little dizzy, or a little numb in a couple areas, which is also goes into the different types of anesthesia we have. We have 4 different types, which is general, regional, local, and sedation. All these look very different, but they're all distributed in many different ways. Either it's through IV, which is kind of just through your kind of bloodstream with veins there, or also through like little tablets they kind of give you before like you're getting like your wisdom teeth pulled out or anything of that nature. It makes you kind of knock out and go to sleep for a couple hours. With these types of anesthesia are a lot of certain outcomes that are kind of specific to each one. They kind of range from sore throat all the way to mortality, which is pretty rare and is not really seen a lot, but many studies have kind of seen that, and many doctors and surgeons have had kind of causes of that nature, which is not very good, but it is a rare outcome of anesthesia that is seen. So the bridge that I'm trying to connect here and make a point on is that studies have shown that genetic variations of certain genes from a genetic standpoint are proven and have been tested to influence individuals' drug response based off of metabolism of certain genes. And this goes into my question of basically, how do genetic polymorphisms influence preoperative or postoperative outcomes of anesthesia? Now, the study I'm using to kind of explain or kind of answer my question is Morocco et al. From 2016. Basically, this paper focuses on the SNPs of the UGT2B7 gene. And their hypothesis is that with these SNPs, do they kind of affect pain sensitivity or fentanyl sensitivity, and also the andesite effects of fentanyl. The way they got to this gene is basically that over the years, fentanyl is being used more than morphine, and the metabolism of morphine by glucuronidation, which is just a metabolic product, it seemed to be influenced by UGT2B7 gene. And the metabolic products of fentanyl are seen to be influenced by this gene, seen to be influenced by fluoridation. So they make the connection between UGT and 2B7, just to make that connection, just to see if the SNPs of this gene kind of affect pain sensitivity for fentanyl and also anesthetic effects of fentanyl. And the way they did this is by certain methods. So they started with a preoperative code reversive boost test, which is basically they hooked an IV up to different patients before a jaw surgery, which is kind of the next method they had. So they hooked the IV up to them, and they distributed fentanyl into them. And basically they tracked down, as what is going to be seen on the next slide, as base pain perception latency, which is going to be PPL, and they recorded as PPL pre, which is before they dunk their hand into this tank of ice. It's very cold, just to see their pain perception. So it's PPL pre, which is before they dunk it in, and PPL post, which is after they took their hand out, and then measured their pain perception latency. And the anesthesia and cosmetic, which is just jaw surgery, that's the scientific name of orthodontic, I think it is. And that's just jaw surgery. And then post-operative pain management, that's just more fentanyl after their surgery, just to make sure they're okay, make sure they're not getting too dizzy or vomiting of that nature. And from that, they took data, went through various genotyping and various statistical analysis. And from that, we get into the results. So they looked at 3 SNPs that they found that kind of showed association and the influence of anesthetic effects of fentanyl in their cold pressure and pain-induced test. And those are the 3 SNPs. And from this one, this is just a table of the association of the clinical data they took from the pain-induced test. So again, you see the PPL pre, which is just before they dump their hand into the tank, and then post is what they're looking at. The arrows and the stars are about the numbers indicate that the genotype, which is these up here, has some correlation when it's looking at the andesite effects of fentanyl. And basically that these kind of influence it. Basically like after they took their hand out of it, they were seen as like an influence, or like this SNP shows an associated influence of anesthetic effects of fentanyl in this test. And this whole row, it was pretty much significant and better than before they dumped their hand, and like the postoperative care when they were doing like the surgery after that. And then also in this table, we see a graph that kind of shows this whole row, and it shows that the C allele is very significant. So we have the CC for this genotype is pretty high here. Then you have CT is pretty high as well. Then you just have TT is very low. That shows that the C allele has some type of correlation, has great influence when you're looking at this S&P. All the other two S&Ps also have the same type of table. Could not fit them all in this presentation. But this one shows the great significance and shows like a major result in their study. And they kind of just show every time in this kind of box or vertical plot that the C allele is very important, and it shows influence of androgen fentanyl. So in conclusion, 3 S&Ps do influence the analgesic effects of fentanyl due to the cold pressure pain-induced test. Now this test was looking at pretty like simple, and looked at just mild pain, which is kind of a limitation in their study that they kind of talked about. Maybe if they looked at more of a severe pain, maybe they would have found more evidence to answer their second part of their hypothesis, which was the influence of fentanyl sensitivity, which they did not find because they only just looked at mild pain, so maybe more severe pain they could have looked at. Many of these studies that I've looked at, just like this one, they don't really answer my research question at all. They just give valid points or clues that point to the fact that, okay, if the metabolism of genes affect their genetic variations, it kind of predicts or influences the outcomes of anesthesia. But there's many other factors that can kind of predict or influence different outcomes of anesthesia. So there's not just one pinpoint answer to that. I think for future work, more studies need to be done with different genes, because different genes and their variations can influence different outcomes of anesthesia. This is just one, but a lot of places I have researched, many other genes have kind of an influence, and also like different alleles in that, like the C, or it can be an A allele as well, they can kind of do that as well. If they just look at that and maybe combine them together, they can probably answer a certain question. And then these are my 2 sources.